This is the payoff. It looked easy, but believe me, a great deal went into preparing for this one shot. Hand loading played a large role in assuring the hunter that he would be successful. It was also a very pleasant way to prepare for the hunt in the off-season. There is a lot of good commercial ammunition on the market today, yet many people continue to hand load. Why is this? There are many reasons. To some, it is a relaxing hobby, as enjoyable as hunting or shooting. Some reload in order to save money, while others feel it is a good way to learn more about firearms and cartridges. Still others own a favorite weapon for which commercial loadings are not available. The majority, however, hand load in order to wring the highest potential from their firearm ammunition combination. Before we go any farther, I should explain that hand loading must be broken into two facets: hand loading for accuracy and hand loading for hunting. The basic process is the same, but the goals are different. When hand loading for target shooting, bench rest competition, etc., the primary goal is accuracy. Hand loading for hunting is what we'll deal with in this video. The hunter wants accuracy, you bet, but he's also concerned with velocity. The secret is to find, through careful development, the load for your rifle that delivers the best possible combination of accuracy and velocity in order to achieve the best performance on game animals. Contrary to popular belief, the most accurate load isn't always one giving low or medium velocity. In fact, in a good many hunting rifles, the best accuracy will be achieved at the top end, where pressure and velocity are concerned.
Setting up a bench with a complete assortment of tools and equipment to make hand loading convenient is expensive. Yet basic hand loading is within reach of nearly anyone's pocketbook. The investment in basic tools is not that great. It is the outlay for convenience features or specialty equipment that adds up. Most people can do without these while getting started. As with any activity involving firearms, safety is a first consideration. While reloading is not considered dangerous or hazardous, you must follow handling and operating procedures recommended by the equipment and component manufacturers. You should also wear safety glasses or goggles at all times to provide additional protection. Do not smoke in the reloading room and give the operation your undivided attention. The basic equipment which is necessary to hand load ammunition includes a press, loading blocks for holding the cases and reloaded ammunition, dies for whatever cartridge is being loaded, a reloading manual, an accurate set of calipers, and a powder scale. Even within this limited list, however, there are many choices to be made. Equipment runs from inexpensive to extremely expensive, depending on what you will ask it to do. Within the realm of loading presses, we see many options, beginning with the small, handheld types such as these. While these will suffice for smaller, easily worked cartridges, they lack the leverage necessary to resize larger cases. Next, we have the bench-mounted press designs, and here the variety grows immensely. This inexpensive C-frame press is strong enough to resize straight wall pistol cases, but isn't recommended for heavier work. Much stronger is the O or closed frame design. The strength of these frames will vary greatly between makes. Some are extremely strong and will handle any chore asked of them, while others are only slightly stronger than the heavier C-frames. Turret presses, while convenient, aren't as popular as standard tools, but they are strong enough to do any job. Also in this category are unique designs such as the Bonanza coax press. While the frame design is nearly as strong as that of most O-frame presses, it offers the advantage of a universal shell holder and a floating die. Instead of threading into the top of the press, the die slips into a slot near the top. While most presses require a shell holder for each individual cartridge, the same shell holder, either in this position or with the plates reversed, serves to hold all cartridges. Finally, at the upper end of the price scale, we find the progressive reloaders. These are intended for volume reloading and turn out a loaded round with every stroke of the press handle. The next necessary piece of equipment is the powder scale. Again, many models are available, varying greatly in price. As a general rule, if a name brand scale is purchased, even the less expensive models are accurate. As the price increases, the convenience of use and generally the speed of use increases. The most important feature is that of accuracy, and the scale should be capable of producing accuracy of no less than plus or minus 1/10 of a grain. Nearly all scales today feature dampened beams, which stop the swing of the beam in a very short time. Loading blocks for holding ammunition are available which will hold virtually any cartridge desired. These blocks come in many styles and configurations, and they are inexpensive enough that it would be ridiculous to do without them. To organize as you reload, it's a good idea to have 2 loading blocks on hand. Dies for each cartridge to be reloaded are a must. This is not the place to scrimp, since the dies are responsible for the case sizing and bullet seating operations. Poor quality dies will do nothing but create problems, while good dies will last a lifetime and help eliminate many headaches along the way. Dial or vernier calipers are used to measure the length of cases to be reloaded and determine when they must be trimmed. You can spend a great deal of money on calipers, and if you can afford it, buy the best. However, inexpensive calipers constructed of nylon will suffice for case measuring jobs. Finally, we come to the reloading manual. This is truly an indispensable item, which will probably see more use than any other. Available from such sources as Sierra, Hodgdon's, Spear, Nosler, Lyman, Hornady, and other manufacturers of equipment and components, a reloading manual provides you with loading data the individual is unable to obtain for himself, and contains a host of information on exterior ballistics.
Today's hand loader should consider a case trimmer essential to the production of safe, quality ammunition. I prefer a rotary case trimmer to a trim file die because in a trim file die the case is sized, and this makes proper head spacing of bottleneck cases difficult. The rotary case trimmers on the market do an accurate job and are relatively easy on the budget.
Peripheral loading supplies needed to get started would include case lube of some sort, powdered graphite or motor mica for lubricating the inside of the case mouths, a deburring tool, a primer pocket cleaner, case mouth brushes, solvent for removal of case lube, a primer flipper, and a powder funnel. In addition, the components must be on hand: empty cases, primers, powder, and bullets, but we will cover these in depth later. Now we come to a list of additional equipment which, while not needed for the loading process, can make the task much easier. These are generally pieces of equipment that perform specialized functions or do a specific job faster. Priming tools come in a variety of shapes and sizes, beginning with the handheld, self-feeding varieties and moving up through bench-mounted automatic feed. They are all designed to perform one function: seat a new primer in the case. This operation can be performed on the loading press, but these units all do the job better. They are designed to seat the primers easily, and the primer can generally be felt as it is pressed into the pocket, so you know when it's firmly seated. Case tumblers or vibrators are another piece of equipment which will seem almost indispensable once you have started using them. Designed to clean cases, they are filled with a medium which cleans and polishes the brass. The vibrator can be used to clean the cases thoroughly before reloading, and again to remove case lubricant after the cases have been resized. Beyond this point, additional outlays for equipment will most likely be to upgrade equipment you already have, or purchase other specific use items as you become aware of what your individual needs are. For instance, you may find that the loads you use tend to stretch cases more than usual. Therefore, you do more case trimming than the average hand loader. It may be that you do well to purchase a power case trimmer to save yourself work. Powder measures are intended for use in conjunction with the scale, and are of no use unless the scale is used to check the charges thrown at regular intervals. Most powder measures employ a hopper located above a drum. As the handle is operated, the drum rotates, dropping a charge from the micrometer tube into the case. When the handle is returned to its starting position, the micrometer tube refills with powder. Adjustment of the charge is made by setting the micrometer tube attached to the powder drum. Again, price will vary somewhat with minor design changes, making some measures more convenient to use. There is an electrically powered automatic scale also available. Rather than being a standard measure, it is more of a combination of powder scale and two tricklers. Once the charge is set, the tray is placed on the scale and the button pushed. A motor begins driving the feed tubes of the two tricklers, one at high speed and one at low speed. When near the charge weight, the high-speed tube stops and the low-speed tube continues until the charge is precise. It gives the added advantage of letting you weigh each charge and is very convenient to use. It also works well with all types of powder. The big disadvantage here, as you may have guessed, is the cost. Before we delve into the actual process of hand-loading ammunition, it would be beneficial if we took a look at the nomenclature of a typical cartridge and what happens as a round of ammunition is fired.
Shown in this drawing is a typical rimless bottleneck case. The parts are the neck, shoulder, case body, case head, extraction groove, and the rim. Sectioned, the internal parts are the primer pocket, flash hole, web, and the solid head. The first step is to chamber a round. Commercial ammo must be made to function in a variety of actions, each of which will have slightly different chamber dimensions. Therefore, the round will chamber loosely in nearly all chambers. When the trigger is pulled, the firing pin moves forward to contact the primer. When it strikes the primer detonates, creating a high-temperature flame that is directed through the flash hole into the case body. This flame then ignites the powder, which begins burning rapidly, but at a controlled rate, generating a volume of gas much greater than the space provided by the case and creating high pressure inside the chamber. This pressure causes that portion of the case forward of the solid head to expand outward, affecting a chamber case seal and pushing the bullet out of the case. The case head is prevented from moving rearward by the breech block, and the case body is held within the confines of the chamber, so the only direction for the gas to move is forward, pushing the bullet ahead of it. When the bullet exits the muzzle of the barrel, the pressure within the chamber drops to zero, and the brass case springs back a little toward its original dimensions. Not much, but just enough that the case can be withdrawn from the chamber.
The firing process is now complete, and the empty case is extracted from the chamber. Now that we have seen the entire firing sequence, we should explain some concepts that should be thoroughly understood before you begin hand loading. There are 4 basic case designs: the rimmed, the rimless bottleneck, the rimless straight wall, and the belted case. The rebated rim case, one in which the head is of larger diameter than the rim, is simply a derivative of the rimless bottleneck case.
All of these cases headspace in a different manner. Before we explain this, let's define headspace. It's the clearance between the face of the breech block and the rear surface of the head of the cartridge in the chamber. When a cartridge is fired, the solid head of the case is moved rearward until it hits the breech block, while the rest of the case remains in place, held firmly against the chamber walls by gas pressure. This causes the case to stretch slightly at the web. As long as there's not too much headspace, such stretching is minimal and does not weaken the case. However, if there's too much headspace, the case stretches and may even separate at the web. If there is too little headspace, the cartridge doesn't fully enter the chamber and the action cannot be closed. The amount of allowable headspace varies with the cartridge, but normally 3 to 4 thousandths of an inch clearance is maximum. Rimless bottleneck cases headspace on the datum line of the shoulder. Rimmed cases on the front of the rim, belted cases on the front of the belt, and rimless straight wall cases on the mouth of the case. Insufficient headspace is rarely a problem, but if encountered, you most likely can't close and lock the action on a chambered round. If you suspect that your rifle might have a headspace problem, take it to a competent gunsmith and have it checked.
The reloading of metallic cartridges begins with the cleaning and inspection of the cases to be used. The cleaning can either be done by using a tumbler or vibrator or by hand. After cleaning, the cases should be carefully inspected, and any with apparent cracks, deep scratches, or deformed rims should be discarded. If a number of cases are damaged, it might be a good idea to investigate and see if you can determine why. A burr in the chamber of the rifle could be causing scratches, while a damaged extractor or ejector could be deforming the rims. If several cases show signs of separation, it could be due to headspace. But then again, it might be because the cases have been reloaded several times and are simply worn out. In our opinion, consistent separation problems warrant having a gunsmith check the headspace. Dents are another consideration. Cases which are severely dented should be discarded, while those with only mild dents or dimples can be used. Again, if many cases in a lot show severe denting, the firearm should be examined. The last common case defect we'll discuss is case bulges. Bulges are nearly always a sign of defects in the chamber, and the rifle should be examined by a professional. Now that all the cases have been cleaned and inspected, we need to lubricate them in order to keep them from sticking in the resizing die. This may be accomplished with either a commercially available lube pad upon which they are rolled, or by lightly coating the fingers with lube and then applying it in a rolling fashion to the case. Take care not to apply too much lube and apply it to the case body only, not the shoulder. Too much lube or lube in the wrong place can result in shallow dents, generally in the shoulder, as the case is resized. The newest and fastest way to lube cases is with a spray such as Hornady's one-shot case lube. Finally, the inside of the case mouth should be lubricated to facilitate easy passage of the expander ball. Use of a carbide expander negates the need for this step, but since most dies use standard hardened steel expanders, lubrication is required. When the cases haven't been tumbled, it's a good idea to use a system whereby the case is pushed down over a brush, at the bottom of which is a reservoir of graphite. The brush cleans the inside of the neck and the graphite lubricates it. When reloading straight-wall pistol cases, it isn't necessary to lubricate inside the neck because the expander doesn't tend to stick as it does in a bottleneck case. Once the cases have been properly lubricated, the case must be resized and the spent primer punched out. Resizing is necessary because the entire case ahead of the solid head, body, shoulder, and neck were expanded out to the dimensions of the chamber when the round was fired. There are two types of resizing, full length and neck. When a case is full length resized, the entire case down to the solid head is squeezed back to its near original dimensions by the die. When a case is neck sized, Only the neck itself is brought back to original dimensions. The remainder of the case is left expanded so it more closely fits the chamber.
For a couple of reasons, I recommend only full-length resizing for hunting. First, a full-length resized case slips easily into the chamber, so you never need to worry about encountering sticky chambering that may prevent the action from closing and locking completely. Second, a round sized in a full-length die can be chambered in other rifles of the same caliber. A neck-sized case will normally chamber only in the rifle in which it was originally fired. There is absolutely no foundation to the idea that neck-sized cases last longer than those that are full-length resized. Neck-sized cases are no more accurate, at least not in hunting rifles, than full-length resized cases. Then, too, after a case has been neck-sized 3 or 4 times, it will have to be full-length resized so that it will chamber. So there's no gain to neck-sizing for the hunter. Instead, the wise hunter will always full-length resize, period.
There are 4 parts to a full-length resizing die. The die body, which resizes the case, the decapping pin, which punches out the spent primer, the expander ball, which brings the inside diameter of the neck to the proper dimension after it's resized, which is about 1/1000th to 1.5 of an inch smaller than the diameter of the bullet to be used, and the lock ring, which is used to adjust the depth of the die in the reloading press. Before you can resize a case, the die must be screwed into the press and properly adjusted. Forget the setup instructions furnished with the die. They tell you to screw the die in till it firmly touches the shell holder. Maybe this is okay, but then again, maybe it isn't. If the sizing die is of minimum dimensions, and the chamber of your rifle and the shell holder are of maximum dimensions, such a setup will allow the case to go too far into the die, pushing the shoulder of the case back. Now, think back to our discussions of headspace. If the shoulder is pushed back, the datum line of the shoulder, the critical head spacing point on a rimless bottleneck case, will also be pushed back, and a man-made headspace will be induced. To properly adjust the die, screw the die into the press until a gap of approximately 1/4 of an inch remains between the bottom of the die and the shell holder. Then, smoke the neck of the case to be resized, or coat it with ink. Place the case in a shell holder and carefully run it into the die. Withdraw the case and examine the neck with a magnifier. Only part of the neck will be resized. Continue to screw the die in, never over a half of a turn at a time, and keep resizing the case until sizing stops exactly at or just slightly forward of the shoulder-neck junction. The case is now sized to preserve the proper head spacing in your rifle. This is often referred to as partial full-length sizing, but in reality, it's proper full-length resizing. Now, run a second case into the die. Withdraw the case only until the neck is free of the neck sizing area in the die. You can feel the pressure decrease. Then, carefully loosen the decapping rod lock nut just a little. This done, continue to carefully withdraw the case until the expander is firmly in the neck of the case. Then, securely tighten both the decapping rod and body lock rings before withdrawing the case from the die. In this manner, the die is positioned as squarely in the press as it's possible to get it, considering the large 7/8 by 14 threads, and the decapping rod is centered in the die. Before proceeding to resize the rest of the cases, resize yet another, wipe it free of all grease, and chamber this case in your rifle. It should chamber easily, and the bolt should close and lock just as it would on a new case. If it doesn't, repeat the previous operation, turning the die down another 1/16 of a turn or so. Fine-tune the adjustment until you're certain it's perfect. Now is a good time to mention that this regulation of the resizing die should apply to all bottleneck cases, whether they are of rimless, rimmed, or belted design. The manufacturing tolerances found in today's brass are considerable where rim and belt thickness is concerned. As a result, proper headspace and maximum case life with rimmed and belted cases can only be achieved if you headspace these cases on the shoulder, just as you do rimless bottleneck cases. Conventional full-length resizing isn't always adequate when semi-automatic or pump rifles are involved. With these actions, which afford minimal camming action to close and lock, it's often necessary to use what's referred to as a low-base sizing die, one designed so that the case enters into the die farther than normal and the case is brought to factory dimensions completely down to the solid head. When such a die must be used, the desired method of setup described before can be employed. Now, begin sizing all of the cases you intend to reload and which have been lubricated. Notice that we dip only every other one in graphite. That's about all that's needed to facilitate easy passage of the expander ball. All straight-walled pistol cartridges and some rifle cartridges require a bullet crimp. If you are loading such cartridges, it's now necessary to expand the inside of the case neck and bell the mouth to afford easy bullet entry. This is accomplished through the use of an expander die, which is included in all 3 die sets. The expander plug in this die has a tapered section that bells the mouth. Adjust the die body and expander plug stem until the mouth is belled just enough to allow the bullet to enter. Caution must be used here so that the mouth isn't belled too much, a condition that will make it difficult for the case to enter the seating die and which will result in premature splits in the case at the mouth. After resizing all of the cases, they should be cleaned of all resizing lubricant. A word of caution here. Some lube makers claim that because of the chemical composition of their product, you needn't worry about wiping it from resized cases. Don't you believe it. If a lubricant, wet or dry, will lubricate the cases during sizing, it will lubricate the cases in the chamber and prevent the case from grabbing and adhering tightly to the chamber walls when it's fired. Likewise, remaining lubricant will pick up dirt and grit that can scratch the chamber of your rifle. Always clean the sizing lubricant from cases until they are squeaky clean. This can be accomplished either by wiping each case with a clean rag saturated with a degreasing agent, or by again running the cases through the vibrator or tumbler for 2 or 3 hours.
If you choose the vibrator again, you'll run up against a perplexing problem for which no one has yet found a good solution: cleaning away the medium that wedges in the flash holes of the primer pockets. Usually, it must be picked out using a sharp-pointed tool.
After the cases are cleaned, they should be measured to make sure they do not exceed the maximum case length specified by the industry. This is where that caliper we talked about comes in handy. If a case that is too long is chambered, it jams into the throat of the rifle, an area dimensioned for the diameter of the bullet, not the outside diameter of the case. When a round is fired under such a condition, the neck cannot expand properly to release the bullet. The result is an increase in chamber pressure. Cases that are too long must be trimmed back to a minimum length. This is usually 10/1000ths of an inch below maximum for bottleneck rifle cases, 5/1000ths of an inch for straight wall pistol cases. The trim to length is a dimension that can be found in loading manuals or in charts provided with case trimming tools. Follow the instructions provided with your case trimmer to set up for trimming. This is an important step and requires attention to detail. Be certain that the proper size pilot is used, and periodically check the length of trimmed cases to make sure nothing has changed. After trimming is complete, the case mouths should be deburred and chamfered. The next step in the reloading process is priming, the insertion of a new live primer into the primer pocket of the case. This can be performed on the reloading press. However, we don't like to prime with the press because it develops so much mechanical advantage that when seating the primer, too much pressure can be exerted and the priming pellet can be crushed. This will result in a misfire or improper primer performance. A separate tool, designed especially for seating primers, does a better and more uniform job. Using any such tool, you can feel the primer into the pocket and know when it is securely seated against the bottom of the pocket. There are basically 4 sizes of American Boxer primers: small rifle, large rifle, small pistol, and large pistol. Within each category, we find 3 designations: standard, magnum, and bench rest primers. The major differences in these will be discussed later. For now, just remember that large primers require the use of the large primer rod or tray, and small primers, the small rod or tray. After priming the cases, place them mouth down in the tray to make sure the primers appear to be seated uniformly. This is also a safety precaution, guarding against double charging a case in the next operation. Before filling the powder measure hopper, inspect the measure and scale to make sure that neither contain powder from the last reloading session. Powder will sometimes hang up in the charge drum, so operate the handle a few times to make sure the drum is clear. The scale must first be zeroed, so follow the manufacturer's instructions for scale setup. The methods of setting the measure vary between models, but in most cases the adjustment is made by loosening the lock nut or screw and adjusting the micrometer in the measuring tube. When setting the measure, it is best to weigh each throw with the scale. Once the powder measure has been set and confirmed by weighing several throws, we are now ready to charge the case with powder. Ball powders and flake powders can usually be thrown quite accurately from a powder measure. Not so for large-grained extruded powders like 4350 or 4831. When throwing charges of ball or flake powder directly into cases, check every 10th charge on the scale. This assures that the powder is metering uniformly and that none of the adjustments of the measure have changed. Each charge of large-grained extruded powder should be thrown into the scale pan and weighed before pouring it into the case. Set the measure to throw charges slightly below the desired weight. Then add the few extra grains of powder required to bring the charge to weight using a powder trickler. It is also a good idea to keep the hopper of the measure at least half full. This helps maintain a uniform powder flow from the measure. As each case is charged, set it in a separate loading block from that containing the uncharged cases. When all of the cases have been charged, hold the loading block under good light and look into each case. Any case which appears to have more or less powder than the others should be emptied and recharged. Charges above or below the desired weight will adversely affect accuracy and can damage the firearm or injure the shooter. Seating bullets is easy once the die is adjusted so that the finished round is of the desired overall length. The parts of the typical seating die for a bottleneck rifle cartridge are the die body, the body lock ring, the seating plug, and the seating plug lock nut. With rifle cartridges in which the bullet is to be seated with a friction fit in the case neck, lock the die so that it lacks about 1/4 inch of touching the shell holder. In this way, the case, with the ram fully raised, will not contact the crimping shoulder in the die. Adjust for correct overall cartridge length using only the seating plug. Seating with a friction fit allows considerable latitude in seating so the cartridge length can be tailored for your chamber. If the bullet is to be held in the case by a roll crimp, the bullet must have a cannelure into which the case mouth is rolled. To effect a roll crimp on an uncannelured bullet will damage the case and bullet and can prevent the round from chambering properly. To adjust the die for a roll crimp, keep the die backed out 1/4 inch and seat the bullet in the case so that the mouth of the case positions about in the center of the cannelure. Then, back the seating plug off and turn the die in just a little at a time until just the right amount of crimp pressure is achieved on the bullet. Lock the die in this position and run the seating plug back in until it's tight against the bullet and lock it. The die is now properly adjusted for seating and crimping in one operation. This works well with bottleneck cartridges and pointed bullets. However, in pistol cartridges, like the 357 and 44 Magnums, it's best to first seat all of the bullets to the desired depth, then remove the seating plug, readjust the die, and crimp all of the bullets in place.
There is yet a third type of bullet crimp, the taper crimp, which is normally required on rimless straight-wall pistol cartridges such as the 9mm Luger and 45 ACP. Because these cartridges head space on the mouth of the case, a roll crimp can't be used. A taper crimp simply squeezes the case in as tight as possible around the bullet without deforming the bullet or changing the length of the case. Okay, now that we have covered the basics of hand loading, let's get down to the nitty-gritty, which involves actually developing a hunting hand load for a specific cartridge. You could simply pick one bullet you would like to use, look up a load in one of the manuals, and load up some cartridges. However, this is simply loading ammo, not load development. When you develop the hunting hand load for your rifle, the purpose is to come up with a load that will deliver the best combination of accuracy and velocity with the bullet or bullet weight you have chosen. To determine this, we will select several bullet and powder types to work with. Using bullets and powders as the constants and powder charges as the variables, we will test different loads at the range to find the best combination. Remember, the success or failure of an expensive hunting trip may well boil down to the performance of this hand load, so do it right.
For the sake of brevity, we'll work with just one cartridge, the famous 30-06. Anything that applies to this cartridge where hunting load development is concerned will apply to any other cartridge on the market. The place to begin is to choose the components you will work with. Let's take bullets first. We will be using our 30-06 to hunt mule deer and elk in the Rockies. So where do we begin? The 30-06 uses bullets of .308 diameter, and there are many brands and weights available. Which will be the best for what we have in mind? Begin by reading what various bullet manufacturers have to say about the .308 bullets they have available. This will give you the manufacturer's recommended uses for their bullets. You find that .308 bullets weighing from 165 to 220 grains are generally recommended for use on elk, while those of 150 to 180 grains are recommended for deer at the velocities generated by the 30-06. You must reach a compromise, and in this case, it's with 180 grain bullets. Since shots in the open country can come at distances of 300 yards or more, choose a bullet of pointed or Spitzer shape. These bullets have a high ballistic coefficient, which means they'll retain their velocity better downrange, thus providing the flattest possible trajectory. The fact that you seem to like a particular brand of bullet does not mean your rifle will. You may have to try several brands before you find the particular one that shoots the best in your rifle. The proper primer must be used when working up loads. There are two sizes of rifle primers, large and small. In each, there are standard, magnum, and bench rest types. Bench rest primers are used mainly for extremely accurate bench rest shooting, so we won't be using them. Cartridges like the 30-30, 30-06, and 300 Winchester Magnum use large rifle primers, while the 222 and 223 use small primers. The choice then is whether to use a standard or Magnum primer. How do you know which one to use? As a rule of thumb, use Magnum primers with most ball powders. With large powder charges, such as those used in most big Magnums, and when you're anticipating a hunt in extremely cold weather. A Magnum primer delivers a hotter flame for a longer duration than does a standard primer. There's no difference in the appearance between Magnum and standard primers, so you must be careful not to use the wrong one when both are on hand. Use of a Magnum primer with a near maximum load developed with a standard primer can result in excessive chamber pressure. When developing hunting hand loads, it's important to use cases of the same make. Then, be sure they are clean inside and out. Selecting the powder to work with in developing your load isn't easy, but a quick check of those used in the loading manuals will tell you which ones the experts feel work best in the 30-06. It's a good idea to have 3 or 4 of the recommended powders on hand, because the one you had in mind to use may not give the results you want.
It's important to choose a powder that will burn efficiently in the barrel of your rifle. If all of the powder burns before the bullet leaves the barrel, pressure created by burning gas decreases and friction will actually cause the bullet to lose velocity while it's still in the barrel. The powders recommended in the reloading manuals are usually the ones that give the best results for a given cartridge and bullet. Remember, the people who develop the data for these manuals have the benefit of pressure measuring equipment. When you start experimenting with powders for which loads are not listed, you're guessing, and this can be dangerous.
With the 180 grain bullets we've decided to use, the manual indicates that 3 of the listed powders we have on hand: IMR 4350, Hodgdon's 4831, and Norma MRP, now marketed as Reloader 22. Why these extruded grain powders rather than some of the ball powders listed? Because in the 30-06, extruded powders will occupy most of the case capacity, resulting in a high loading density, which helps accuracy. If none of these give the results we want, then we'll try some ball powders. Since we will be using extruded grain powders and don't anticipate hunting in extremely cold temperatures, we will be using CCI 200 standard large rifle primers. Standard and Magnum primers burn at different rates, and this is true for pistol, large pistol, rifle, and large rifle primers. Different ignition rates will produce different burning rates with any powder, thus affecting chamber pressures. Different lots of the same primers will also ignite at different rates, so don't make the assumption that another lot of the same primer will perform exactly the same. We are using 3 different powders. With each powder, we will use 3 different brands of bullets. Each bullet and powder combination will be tested with differing powder weights. Now that we have the components, clean cases, primers, powder, and bullets, we must now determine the maximum overall cartridge length for our rifle.
Overall cartridge length and bullet seating depth are misunderstood by many hand loaders. If the bullet isn't seated deep enough, it jams against or even into the lands of the barrel. This causes high chamber pressure because the bullet must be forced into the barrel from a dead stop. If the bullet is seated to a depth just back from the lands, say 20 thousandths to 35 thousandths of an inch, it's moving before it hits the lands and it takes less pressure to push it into the barrel. However, you don't want too much distance between the bullet and the lands. The farther it has to move, the greater the chance of it being out of alignment when it enters the bore. There are a couple of ways overall length can be determined. One method, which only works well with bolt-action or single-shot rifles, is to insert the bullet you intend to use into the chamber. Then use a short cleaning rod to hold it in place against the lands of the barrel. Insert a cleaning rod with a flat-nosed jag tip in it from the muzzle until it touches the nose of the bullet. Mark the rod at the muzzle of the barrel with a fine felt-tip pen. Now, remove the bullet and close the action. Again, insert the cleaning rod from the muzzle until it stops against the breech block. Then, make another mark on the rod with a felt-tip pen. With a caliper, measure the distance between the two marks on the rod. Theoretically, this is the maximum overall cartridge length for our rifle with that particular bullet. However, this length puts the bullet touching the lands. We want it seated 20 thousandths inch off the lands, so deduct 20 thousandths from the overall length to arrive at the proper length. Next, make up a dummy round, without powder, to this length. With a heavy black felt tip marker, color the bullet completely. Carefully chamber and extract the dummy round and examine the bullet with a magnifier. If there are no marks where the lands touch the bullet, you have the correct length. If landmarks are present, set the bullet back another 20 thousandths. Coat it with ink again, chamber and extract it. This time your length should be correct. Another method is to bend the mouth of a fired, unsized case just enough that it will hold a bullet, but allow the bullet to slide with slight pressure. Start the bullet into the case, chamber it, and close and lock the action. Carefully extract this round and measure its overall length. Deduct 20 thousandths from this measurement. Make up a dummy round to this specification. Coat the bullet with ink and check the length as we did for the first method. When the overall length is correct, be sure to make note of it.
When working up loads, all of the cases should be prepared by first resizing, then trimming them to the proper trim-to length. By doing this with 50 or 100 cases, you'll use up less range time than if you work with only a few cases, loading them time and time again during load development. If things work out right, you'll have enough cases left to load up the ammunition you need for the hunting season. When seating primers, uniformity is the name of the game. Each primer should be seated to a uniform depth solidly against the primer pocket. However, it is possible to seat the primer with too much pressure. The danger here is that the priming pellet could be cracked or broken and a misfire could result. But when seated with too little pressure, we have a high primer condition, where the anvil of the primer isn't solidly supported on the bottom of the primer pocket. Again, a misfire could result. Of greater danger, though, is that a high primer could detonate when the action is closed, or the firing pin might puncture the primer, releasing high-pressure gas back into the action. Once you have primed some cases, it's time to charge them with powder. Don't prime them all, because you may find it necessary to switch brands of primers before you're through with your development. First, a word of caution. Don't try to interchange the same numbers in different brands of powder. They are different and have different burning rates. And never, under any circumstances, mix powders. Violation of these two rules will sooner or later result in a serious accident. The place to start is with the lightest charge listed in the book. Never start at the top of the chart. Start at the bottom and work up. Even when a load has already been developed, it must be reworked any time any of the components change. Different lots of the same primers and powders will show slightly different burn rates, thus changing chamber pressures. While working up loads, using powders with slow burning rates, such as IMR 4350 and Hodgdon's 4831, the charges may generally be increased in increments of 1/2 of a grain. With faster burning powders, such as H322 and 4198, increase in increments of 1/10 of a grain. If you don't have access to loading equipment at the range, load and label 3 cartridges of each load you have selected for test firing, beginning with the lightest powder charge. Be aware, however, that you may have to pull the bullets from some of them if maximum pressures are evident before you reach the highest charge you have prepared. Keep in mind that temperature and humidity have a marked effect on the burning rates of powders. Therefore, a marginally safe load, which was developed during cool weather, may exceed the maximum pressure in your firearm if used during hot weather. This is one of the reasons that ammunition should never be carried around lying on the dashboard of a vehicle or laid in the sunlight for extended periods. We are working up loads at the range. If it is possible for you to do your load development at the range, we recommend you do so. Again, start with the lightest charge shown in the book. Load 3 rounds and fire them at a target. Look for accuracy and signs of pressure. At the first sign of pressure, consider that load maximum. In most hunting situations, the highest priority will be given to velocity, with accuracy being second. This is especially true of big game loads, where accuracy in the 2-inch range is often acceptable. In varmint loads, accuracy is more important, but here we will be dealing with loading for big game hunting.
What pressure indicators do we look for? 2 of the most reliable are hard bolt lift, any noticeable increase in the force required to lift and unlock the bolt, and sticky extraction, or both. Dirt in the locking lug recesses or a dirty chamber can cause these things, but unless you experience them with factory loads or the lowest hand load listed, hard bolt lift or sticky extraction should be considered indicators of higher than normal chamber pressure. If either of these indicators show up, go back to the previous load where you did not experience pressure and consider that load maximum. Many reloaders view primer condition as a pressure indicator. This may or may not be true. A flat primer may be the result of too much pressure, or it can simply be caused by a soft primer cup. On the other hand, a primer with an abnormally hard cup may not flatten with high pressure. Cratering, or a raised ridge around the firing pin indentation of the primer, is most often caused by an oversized hole in the breech face through which the firing pin passes. However, if cup metal flows back into the firing pin indentation or the primer pierces, suspect high pressure and back off your powder charge. On rifles having a plunger type ejector set in the bolt face, this can warn you of high pressure. If an examination of the case head after firing shows the imprint of the ejector on the face of the rim, back off the powder charge. There is another method of determining high chamber pressure, but it requires an accurate micrometer and careful attention to detail through the measuring process. Here's how it works. Fire a factory round in the rifle and extract it. With a file flats on the rim, one opposite the other. This is necessary so that the micrometer can be passed over the rim. Very carefully measure the solid head of this case and jot down this measurement. Now, using the same case, reload it and fire. Again, measure the case head. The solid head should not expand. An increase in diameter of just 5/10,000ths of an inch signals high pressure, and the load must be cut back to the last one in which no expansion was measured. This is probably the most reliable method for the reloader to monitor chamber pressure. But as I said, to do the job right, you need the proper tools and skill at using the micrometer. A chronograph can be invaluable in evaluating load performance. Fortunately, there are several battery-operated chronographs available to the shooter. The chronograph will not only tell you the velocity of your loads, but will clue you in if the powder you're using isn't burning properly. Extreme velocity spread in a 10-shot string, 100 feet per second or more, can mean that the powder is burning erratically. Most important, though, the chronograph tells you exactly what the velocity of your load is in your rifle. Invaluable information, as we'll see later. By now, we probably have found the maximum safe load for our rifle with one set of components. Change any component and you must begin all over again. But now we must assess the accuracy of our load. It's an old wives' tale that reduced loads are always more accurate than the maximum loads. In fact, with sporting rifles, I more often find the opposite to be true. Nevertheless, you must now decide what you want from your .30-06 in the way of accuracy. Remember, you are developing a hunting load. It's usually more desirable to choose a load that delivers maximum velocity, even if it means sacrificing some accuracy. I'd rather have a .30-06 load that produced 1 1/2 or 2-inch groups at 100 yards with the 180 grain bullet, leaving the muzzle at 2750 feet per second, than I would one with the same bullet that shoots 3 shots into 1 inch, but at a muzzle velocity of only 2600 feet per second. After all, you'll need all of the velocity you can get for that bullet to penetrate and expand properly out there at 300 or 350 yards. Once you're satisfied with your load, go ahead and reload whatever quantity of ammunition you will need for sighting in and the hunting season. If a chronograph is not available, the velocity can often be estimated by using the reloading manual. Simply select, in the manual, a bullet of the same weight and style you used. Go down the list of powders to the one you used, then to the charge weight column, and read what their velocity was. The velocity of your load should be close enough to give you an idea of how it will perform. Sierra Bullets has a handy exterior ballistics program for personal computers that will tell you just about anything you wish to know about how your load will perform. All you have to do is load the program into your computer, call it up, fill in the blanks, and watch it work. You say you don't have access to a computer either? Again, Sierra to the rescue. For a nominal charge, you can send them the pertinent information on your load, and they will send a printout from this program. The card listing the information you need to send can be found at the back of the Sierra manual. Now the work is done and the load is developed. All that is left is to properly sight in your rifle and take to the field. When the chance comes and you set that crosshair on the chest of a trophy, you can squeeze the trigger with the confidence that only comes with knowing your hand load has been developed for top performance at just this moment.